All right, hello class. Thank you so much for joining me today. So what we're going to be doing today is introducing a set of tools called game theory, which are really about trying to analyze situations where people interact with each other and are able to affect each other's decisions. In other words, we're going to want to think about situations where what's best for you to do, how you're going to want to react to a situation, depends in various ways on how I'm going to react to the situation, and vice versa. So up until now, we've really been able to dodge these questions in this class by focusing on two very particular types of situations. The first is competitive markets, where effectively there are no concerns about how my actions depend on your actions or vice versa, because nobody has any power, right? In a competitive market, you go to the grocery store, you buy the apples and bananas that you want, and you don't think at all about how your decisions influence other people's decisions, because you're just a tiny irrelevant speck in the great cosmos universe of our economy, right? So that's one set of situations, nobody has any power. The other situation we've talked about is market power, where you have one individual with effectively all of the power, right? You have a monopolist who can set a price, and everyone else just reacts to what the monopolist does, right? But individuals who are buying commodities don't have any counter power. So in those situations, we don't need to worry about strategic interactions between individuals. But in any other situation we want to think about, we do. So this will include thinking about, contract negotiations between two individuals who have power. It'll involve thinking about public goods, right? Shared investment in some common project that's going to benefit multiple people. It's going to play a role thinking about things like multiple companies, each of which have some market power, reacting to each other's optimal market positions. Wonderful. So it's one of the most flexible, one of the most interesting, one of the most powerful tools that we can learn in economics. I'm very, very excited to share it with you today. Okay, so let's start out with a classic game theory scenario. So let's imagine tomorrow night, you get a call from President Elam asking you to wait for him on Alumni Road at midnight. So you get out there, his red Ferrari squeals up, tells you get in the car, and takes you out to Pomona College to steal the Pomona College mascot, which, if my research is correct, is the sage grouse, which is very strange. So drive out to Pomona, grab the sage grouse mascot, throw it in the back of his Ferrari, start getting out of town when you get pulled over by the Pomona police. So at this point, they have definitely proven, right, easy for them to show that you're in possession of a stolen sage grouse, which is going to have a penalty of 2 months of community service. Right? But they haven't been able to prove that you yourself stole the sage grouse, right? You tell them some cockamamie story about how you just saw it sitting on the road and you figured it'd be safer with you than out in the street. If they're able to prove that you stole the sage grouse, then they'll give another 8 months of hard time. But because they only saw you with the sage grouse, they can't disprove your alibi. The only way that they're going to get you for theft is if one of you confesses to possession. So at this point, the Pomona College cops offer you a deal. Pull you and President Elam into different rooms, and they say, listen, if you'll admit that President Elam stole the sage grouse, we'll let you off from the possession charges, right? No community service for you. But if President Elam confesses to stealing the sage grouse with you, and you don't say anything, then we're going to get you on possession and theft, so you're going to end up having to serve 10 months of hard time. So the question then is, what should you do? And what should President Elam do? Right? So to figure this out, there's a couple things that we need to know, which I'll call the elements of the game. So first of all, you're going to need to know your objectives, right? So at this point, we might imagine for you and President Elam, your objectives are very simple. You want to avoid doing community service as much as possible, right? You don't care about each other. We need to know what your choices are, right? What your possible plays are going to be. So in this case, we might think your choices are either to confess to stealing the grouse or not. We need to know your payoffs, which is to say the consequence of each of your choices for you. We need to know the rules. You know, do you find out whether President Elam talked before you decide to talk? Can you guys coordinate ahead of time, et cetera, et cetera? And you need to have knowledge of each other. Right? In other words, do you know, you might know your own objectives, but do you know President Elam's objectives? Do you know his choices? Do you know his payoffs? So these 5 elements constitute a game, and given these 5 elements, we're going to try to develop a set of tools to figure out what the outcome of each situation is. So in this situation, I'm going to write out the potential choices and payoffs in the form of what I'll call a 2x2 game matrix. What that means is, I'll say for you, there are going to be 2 choices, right? You can either shut up, or you can talk. And for President Elam, there are going to be 2 choices. He can also shut up or talk. Right? So these are essentially our set of choices. Our rules, in this case, because you're both being brought into separate interrogation rooms, you can't talk to each other, is that you make your decisions simultaneously. In other words, you don't get to know whether Elam confessed before you decide whether you ought to confess. So how about your payoffs? Well, if all you care about, right, is avoiding community service, then if you're quiet and Elam's quiet, then you're going to get 2 months of community service. He's going to get 2 months of community service, right? So I'll say your payoffs are -2, and his payoff is -2. I'll separate your payoffs from each other by a diagonal line so that it's clear who goes where, right? How about if President Elam's quiet and you decide to talk, you decide to confess? Well, then you're not going to get any time at all, right? Because you'll get off on the possession charges and they won't have any evidence for you on the theft charges, right? You'll say that Elam did it. So you'll get a payoff of 0. But poor President Elam, right, he's going to get stuck with possession and theft charges. So he's going to have a payoff of -10. Same thing if President Elam talks, right, and you're quiet. He's not going to get any charges at all, whereas you're going to be stuck serving 10 months. And finally, if both of you talk, right, both of you will get off on possession. Both of you are going to get hit with theft. So you're going to have -8. Elam's going to have -8. So these are your payoffs, right? These are the consequences of the decisions that you make that also depend on the decisions that the other person makes, right? That President Elam makes. So now the question is, what should you do? And is what you do, is what's the best move for you, dependent on what you know about President Elam. So to think about this, let's think about what makes this hard. Right? The challenge here in knowing what you ought to do is that you don't know what Elam's going to do, right? You don't know whether he's going to be quiet or whether he's going to talk. So let's start by thinking, what if we did know the answer to that? Right? What if we knew for sure that President Elam was going to be quiet, right? We knew he wasn't going to talk. So in that case, right, all we have to worry about is our best move, given that President Elam's going to be quiet ourselves or to talk. Well, in this case, right, we'll get 2 months community service if we're quiet. We'll get no community service if we talk. So our best response to President Elam being quiet is going to be to talk, right? Where our best response refers to our optimal move conditional on the other player's move. right? So if Elam decides not to talk, our best move is to talk, because 0 is better for us than -2. How about if Elam decided to talk, right? If we knew for sure that he was going to snitch on us. Well, in this case, right, if we're quiet, we're going to get 10 months. If we talk, we're going to get 8 months. 8 months is better than 10 months, right? So our best response to Elam talking is going to be for us to talk. Now, what this means is, well, the payoffs we get depend on whether Elam decides to talk or not. In this case, our best move does not depend on whether Elam decides to talk or not. Right? Regardless of what Elam does, our best move is to talk. So what we'll say is that shutting up is dominated, strictly dominated by talking. In other words, we know for sure that it's never going to be best for us to shut up. So we'll say a dominated strategy is a strategy that's worse than some alternative for any move that the other player makes. So, if there's a strategy that's dominated, right, like in this case, the strategy of shut up is dominated, then it doesn't matter what you think Elam's going to do, your best move is going to be to talk. So that's your perspective, right? Let's think about this from President Elam's perspective. So for President Elam, we're going to have the same problem, right? If he knew for sure that you weren't going to talk, he would compare the payoff from -2 and from 0, and his best move would be to talk. Right? If he knew for sure that you were going to be quiet, he would compare -10 to -8, and his best move would be to talk. As a result, for him as well, right, shutting up is going to be a dominated strategy. So what this means is there's only one possible outcome of this game if both of you only care about yourselves and only care about getting out of community service, which is that both of you confess on each other, both of you end up serving 8 months of community service. So, right, this outcome, talk, is going to be the consequence of each of you making an individually optimal decision. Is this going to be a Pareto optimal outcome? In other words, is the consequence of both of you doing what's best for yourselves going to be an outcome that can't be improved upon from both people's perspective? Would it be possible to make you better off without making President Elam worse off? Well, the answer to this is clearly yes, right? Both you and President Elam would be better off if you were both quiet, right? If you both shut up, then you would each serve 2 months of community service, which is better for both of you than you both serving 8 months of community service. But this better outcome, right? This outcome that's better for both of you is never going to happen as long as you're both behaving selfishly, because it's in neither of your interests to move from here to there, right? In other words, it would help President Elam for you to be quiet, but it would hurt you to be quiet, right? It would help you if President Elam was quiet, but it would hurt President Elam to be quiet. So as long as you're both in control of your own actions, and you're both behaving selfishly, you'll never be able to get to an outcome that's better for both of you. One thing I want to point out here, right? We talked about kind of you guys being put in separate interrogation rooms. If you're both truly selfish, and this is truly the payoffs you get, this outcome would occur even if you were sitting together in a room and you could make an agreement, discuss amongst yourselves as long as you possibly wanted. Right? You would never be able, if you both knew that the other person was selfish, if you both were selfish, actually regardless of what you knew about the other person, you would never be able to deviate from this mutually destructive outcome. So I imagine you guys might have seen The Prisoner's Dilemma before. The reason that I wanted to start with this, the reason all economics classes tend to start with this when we talk about game theory, is because this is kind of the horrible, destructive, sad, opposite conclusion that we come to when we talk about the welfare theorems in competitive marketplaces. right? And we talked about the welfare theorems. We talked about this really remarkable positive outcome, where we said each person makes their own decisions for their own best interest, right? And in a competitive market, each person making their decisions for their own best interest results in some outcome that's also in some sense best for society, right? That's Pareto efficient. Here we're saying the exact opposite, right? When each person behaves selfishly, when each person does what's in their own interest, we can end up with this mutually destructive outcome, right? Where everyone is worse off than they could be if they could cooperate, but no one has any individual incentive to cooperate. So in some sense, this is a very, very, very sad story, right? And it's the core of many of the deep social problems that we have as a society, right? If we wanted to think about avoiding pollution, if we wanted to think about, providing goods to our mutual benefit, if we wanted to think about avoiding war, all of these problems are going to be versions of the prisoner's dilemma. On the other hand, there's a really hopeful side of this, a really positive side of this, which is that in real life, in many circumstances that look like prisoner's dilemmas, we actually manage to cooperate and avoid the destructive outcomes, right? There's lots and lots of circumstances where people are willing to give up personal gain in order to be part of a cooperative and social equilibrium. And in fact, when people do prisoner's dilemma style games in labs, right, behavioral economists do experiments, the only people who really behave really selfishly like this are economics undergrads who have been taught the prisoner's dilemma, right, and then therefore believe that the proper way to play, or the right way to play, is to play selfishly. Okay, great. Let's do another example using these same sets of tools. So let's imagine that Coke and Pepsi have vending machines right next to each other, and they're trying to decide how much to charge. And for now, let's imagine that nobody really cares whether they drink Coke or drink Pepsi, which I know is the opposite of true. So all the customers are going to go to whoever charges the lowest price. And we'll imagine that the demand for soda at this vending machine is given by Q of P equals 10 minus P. Right? So there's some linear downward sloping demand for soda. To keep these things simple, let's imagine that Coke can charge one of three prices. They can either charge $4, what am I doing? $4, $3, or $2. And Pepsi's got the same choices, right? So Pepsi 2 can charge $4, $3, or $2. And again, just to keep these things simple, let's imagine that the soda is free to them, right? Their marginal costs are 0, or round down to 0. So their objective is just to get as much revenue as they possibly can. So if we think about these rules, right, so our objective is to maximize P times Q, right, our revenue. The rules are going to be, they're going to choose their prices simultaneously. Right, and let's imagine that their payoff is going to depend on whether they've got the high price, the low price, or a tie. Right, so whoever is charging the lowest price is going to get all of the customers, but if the two companies charge the same price, they'll split the customers in half. So as a result, right, they're both charging $4. Then they'll have, right, a total demand is going to be 10 minus 4 is 6. Each of them will sell 3 cans of soda, right? So each of them are going to get $12 in revenue, right? 12 for Coke, 12 for Pepsi. I'm just now realizing I used the wrong colors. Hopefully that's not giving you an aneurysm. However, right, if Coke was charging $4 and Pepsi charged $3, Coke's not going to get anything, right, because they're going to be the high price. Pepsi's going to get 10 minus 3 is 7 sales at a cost of at a price of $3, so they're going to get $21. And then, if Coke charges $4, Pepsi charges $2, Coke's still going to get nothing, right? Pepsi's going to sell 8 cans of soda at $2 each, so it's going to get $16. Cool. Now, equivalently, right, if Pepsi charged $4, Coke would get 21 if Pepsi would get nothing if Coke charged $3, right? And Coke would get 16 while Pepsi got nothing if Coke charged $2. Now, what if they both charged $3? In that case, right, they'd again split the total revenue. So there would be a total of 7 cans of soda sold, right? 3.5 for each. 3 times 3.5 is going to be $10.50. So they would each get $10.50 in revenue. I know I'm kind of blazing through this. I'm hoping to get, the real point of this is going to be once we've got the game set up. If Coke continued to charge 3, Pepsi charged 2, then Pepsi would be the low price, right? So they'd again get $16. Same deal if Coke charged 2 while Pepsi charged 3. So then the only thing left is what happens if they both charge $2, in which case, right, they're going to split the total sales. There will be 8 cans sold, 2 for each, at a price of $2 means they'll each get $8. Great. Okay, so this is our set of payoffs, right? Let's think about whether we can figure out what the outcome of this game is going to be. So let's start by thinking about Coke's perspective, and again, try to figure out Coke's best response to each price that Pepsi might charge. Right, so let's say that Coke knew that Pepsi was going to charge $4. Then their choice is, do I want to make 12 bucks, 21 bucks, or 16 bucks? The answer is super clear, right? They're going to want to charge $3 so that they can make 21 bucks. What about if they knew that Pepsi was charging $3, right? So they could ignore these. In this case, they would decide, do I want to make nothing, $10.50, or 16? Well, clearly, right, they're going to want to make $16, right, by charging a price of 2. And if they knew that Pepsi was charging a price of $2, their choices would be, do I make nothing, nothing, or 8? Clearly their best choice is going to be $8. Right, so their best response is going to depend on Pepsi's decision. Right, they charge 3 if they knew Pepsi would charge 4, otherwise they'll charge 2. Let's think about Pepsi's best decisions. Well, Pepsi knew that Coke was going to charge $4. Their best choice is going to be to charge $3 and get a payoff of 21. Right? If they know that Coke is going to charge $3, right, they know we're in this middle column, their best choice is going to be to get $16 by charging 2. And if they know that Coke is charging $2, their best move is going to be to charge $2 so they can at least get 8. Cool. So what do we do from here? The problem is, I can no longer rule out any decisions, or I can no longer decide what the best move is going to be in all possible circumstances. Right? My best move as Coke is going to depend on what Pepsi does. My best move as Pepsi is going to depend on what Coke does. However, I am going to be able to rule out some choices. Right? If I'm Coke, it's never a good move for me to charge $4, right? Regardless of what Pepsi does. So I know that $4 is strictly dominated. Right? It's always worse than charging $3. And for that matter, always worse than charging $2. For the same reason, right, we know that Pepsi is never going to charge $4. Right? Again, it's strictly dominated. So we can take this out. Right? $4 is going to be worse than $2, regardless of what Coke decides to do. So what do we know from here? Well, if we knew, if Coke knows Pepsi's payoffs, right? If Coke knows Pepsi's payoffs, then Coke knows that Pepsi will never charge $4. So Coke can forget all about this column here. And in that case, right, if Coke knows that Pepsi's $4 choice is dominated, then Coke's only going to consider these two choices, right, $3 versus $2, and it'll be totally clear to them that $2 has to be the better move. Right? Once we disregard the possibility of Pepsi charging $4, then $2 strictly dominates $3. And exactly in the same way, right? If Pepsi's deciding their choices, if Pepsi knows that Coke's never going to charge $4, then they know that $2 is always going to be better than $3. So they'll also decide to charge $2. So we call this iterative dominance. And the idea is essentially that if we can systematically rule out options until we come to one final, that's going to be the outcome that happens so long as each player knows the other player's decision-making process, right? Knows the other player's payoffs. So iterative dominance requires a little bit more from us than pure dominance, right? In the prisoner's dilemma game, we don't need to know anything about the other person we're playing with to know what our best move is. Here, we have to understand the decision-making process of the other player. Okay, fantastic. Thank you so much.